Let's explore some Docker performance tips. These simple optimizations can help make Docker run faster. One way to reduce the size of your Docker images is to use Alpine Linux as a base image. Instead of using a larger image, such as Ubuntu version 20.04, consider using a smaller image like Python version 3.9-Alpine. For even better results, you can use multi-stage builds. In the first stage, use Python version 3.9-Alpine as the builder, copy the requirements file, and run pip install with the user flag to install dependencies. Then, in the second stage, use Python version 3.9-Alpine again, and copy the installed dependencies from the builder stage to the appropriate directory. Optimizing Dockerfile layers can significantly improve build times and image size. Combine multiple run commands into a single one. This reduces the number of layers created. Also, copy dependency files first. Copy the requirements file and install the packages before copying the rest of the application code. This leverages Docker's caching mechanism, making subsequent builds faster. To speed up the build process and reduce the size of your Docker images, use a .dockerignore file. List files and directories that are not required in the image, such as node modules, .git, .gitignore, readme.md, .env, .nyc_output, coverage, and .ds_store. This prevents unnecessary files from being included in the image. Enable BuildKit to take advantage of performance improvements and advanced features. Set the environment variable Docker_BuildKit to 1. Use the build cache to reuse layers from previous builds. You can specify a cache source using the cache from flag. Also, leverage BuildKit's cache mount feature to cache dependencies during the build process. For example, you can mount the pip cache directory to persist installed packages between builds. Setting resource limits for your Docker containers helps prevent them from consuming excessive resources and impacting the performance of your host system. When running a container, use the memory flag to limit the amount of memory the container can use. Similarly, use the CPU's flag to limit the number of CPUs the container can access. In Docker Compose, you can define resource limits under the Deploy section for each service. Specify memory and CPU limits to ensure fair resource allocation. Optimize volume usage for better performance. Use named volumes instead of bind mounts whenever possible. Named volumes are managed by Docker and generally offer better performance. Avoid using bind mounts for heavy input-output operations, as they can be slower. Use tempfs for temporary files. This stores files in memory, providing faster access. You can also cache node modules by declaring a volume for the app node modules directory in your Dockerfile. Implementing health checks in your Docker containers allows Docker to monitor the health of your applications and automatically restart unhealthy containers. In your Dockerfile, use the health check instruction to define a command that checks the health of your application. For example, you can use curl-f to check if your application's health endpoint returns a successful response. You can also configure health checks when running a container using the health command, health interval, and health retries flags. These flags allow you to customize the health check parameters. Optimizing network settings can improve the performance of your Docker containers. Use host networking for better performance, especially when network latency is critical. You can specify network equals host when running a container. Create custom bridge networks to isolate your containers and improve security. Use Docker Network Create to set up a custom network. Enable DNS caching to reduce DNS lookup times. You can specify DNS servers using the DNS flag. Reduce network overhead by using the init flag when running containers. This ensures that a proper init process is used, which can help prevent zombie processes and improve signal handling. To ensure optimal performance of your Docker containers, It's essential to monitor their resource usage and identify potential bottlenecks. Use Docker stats to monitor CPU, memory, and network usage of your containers in real time. Check container logs using Docker logs to identify errors or performance issues. Inspect container details using Docker Inspect to view configuration and metadata. Consider using dedicated monitoring tools like cAdvisor or Prometheus for more advanced monitoring capabilities. Docker Desktop also provides insights into container performance. For performance profiling, you can use tools like TOP or PSAUX inside the container to identify resource-intensive processes. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.